Okay, so we're going to look at a couple of word problems, and I've highlighted some information already. It says Molly's throwing a beach party. She still needs to buy beach towels and beach balls. Towels are $3 each, and beach balls are $4 each. Molly bought 10 items in total, and the cost is $34. How many beach balls did she get? Okay, so this asks for just beach balls. But in order to find beach balls, we have to find both of them. So what we're going to do, or what I've done, is gone through, and the first thing that pops up, I labeled it X. So our beach towels are X, and the second piece of information is Y. You could use T and B. It doesn't really matter what letters you use. Now, the next sentence tells us that towels are $3 and beach balls are $4. So I'm going to go ahead and write these two sentences together. So far, they've told us that we have $3 beach towels and $4 beach balls. So this is what we have. And we have bought 10 items, and they cost $34. So because these two numbers that I've written down are dollar amounts, I'm going to keep this 34, which is a total, with this sentence. Now, I also have another total of $10. 10 items. So we know that the items that we have are towels and balls, but we don't know how many of each, so we just represent those with X plus Y, because if I add the number of both of them together, then I'll get 10. Now this looks like one of the problems that we are doing with substitution, so you could solve that from here and figure out how many beach balls that Molly bought. I want to take a look at another one, because there's another type of these equations. And I like to use this one a lot, so I want to make sure to walk through it with you. And the school that Imani goes to is selling tickets for the annual dance competition. On the first day of ticket sales, she sold 3 senior citizen tickets. This is the first type of ticket that pops up, so I've labeled it X. So that is 3X. And is a plus sign. She also sold, or they also sold, 3 child tickets. So we also have 3Y for $69. So that 69 is a total that we sold on that day. The school took in $91 on the second day. So this time they put the total in the front, so just be careful with that. And they got $91 for selling 5 senior citizen tickets. So remember, our senior citizen was X, so that's 5X, and 3 child tickets, so 3Y. Now this is set up nicely. If you notice, none of the variables have a coefficient of 1, but we do have a variable that matches exactly. So in the next thing I'm going to show you is how to do elimination. When you're looking for elimination, you're looking for something that matches exactly, so that when I add or subtract the totals, I can eliminate them or cross them out. So in this case, because they're both positive, if we subtract these two equations, 3 minus 3 is 0, and it cancels out. Now I can do the rest of the problem, and you'll see 3 minus 5 is negative 2x, and then I have to do 69 minus 91, and I need a little bit of math help here, so just a second. Okay, so negative 22. Now, if you look at this, this is crazy. We already have a value for x. X is 11. So we know the price of a senior citizen ticket is 11, because that is what we let our x be, right? Now we can also find, let me write that for you. We can also use that information, plug it back to either equation 1 or equation 2, and find a value for a child's ticket. So I'm going to use the top equation just because it's first. So 3, And then I'm going to replace the x with its known value of $11. So that's $33 for adult tickets. How much was a child ticket? So I'm going to keep writing and find out here. I'm going to subtract that 33 from 69. And then divide by 3. Oh, goodness. Child's tickets are more expensive. Who knew? Now, because it's a word problem, you can write your answer in a sentence, or you can put it as a point. The question says, what's the price of a senior citizen ticket and one child ticket? So these answers are fine. Or you can write it as the point 11, 12, x comma y. So $11 and $12 for tickets. Okay, I'm going to do some more examples of elimination. So just one second. In this example, we have 5x plus y equals 6 and 3x minus 4y equals 22. Now, some of you are saying, I can do this with substitution. I'm going to use substitution. That's fine. You can solve for y and use substitution. Some people loathe substitution, so I'm going to show you another way. We want one of our variables to be the exact same number so that they eliminate. 5 and 3 are not the exact same number, but I could manipulate both equations. I can multiply the top equation by 3 to get 15, and the bottom equation by 5 to get 15, and then they would eliminate. That seems like a lot of work to me, so I'm going to check the next variable. Okay, this one is better. You see how one's positive, one's negative? It's already set up for us, and because there's a 1 here, I can multiply this by 4, and these two would eliminate each other. So I'm going to multiply the top equation by 4. And that's going to give me 20x plus 4y equals 24. Now, if I add these two equations up, I don't need the top equation anymore. I've replaced it with itself times 4, and I'm going to add straight down, combine like terms here. 3 plus 20 is 23x. Negative 4 plus 4 is 0, so they eliminate. And then 22 plus 24 is 46. So very easily here, with one manipulation from me by multiplying by 4, I can divide by 23 here and get that x is 2. Now we need y. You can't say you're done without finding y. We have 3 equations now. Either one of them will find y for you. I'm going to use my original first equation before I changed it because it's the prettiest to me, and by that I mean y is already by itself right here. There's no coefficient. We won't have to do that extra step, but it really doesn't matter. So I'm going to replace the x that I found with 2, and then solving this equation here, I find that y is negative 4. So we are finished. We just have to write our answer as 2 comma negative 4. If you got it, great. Go ahead and do your homework. I'll teach you how to do triple equations in the next video. If you would like another example, I have one for you. Sorry about the noise. Okay, so the next example, if you need it, is 7x minus 3y equals 2. And the second equation is 2x plus 6y equals negative 20. Okay, so take a second. See if you can figure out how we can make one of the variables match exactly. Okay, some of you might have seen that we can make this x 14x, but we'd have to multiply both equations. So myself, I like the idea of multiplying the top equation by 2, because this will give me a negative 6 and a positive 6, and that makes 0. So I'm going to do the top equation times 2, and I'm going to write it right here. So that's 14x minus 6y equals 4. Notice I'm multiplying every term in that equation by 2. If you leave one off, you'll unbalance the equation and you'll get the wrong answer. So be very careful there. Okay, now add like terms. Again, I'm done with equation 1. I've moved on, and I'm going to add 14 and 2 to give me 16x. The y's cancel, and negative 20 plus 4 is negative 16. So very quickly, you'll see that x equals negative 1. See? Now I can plug that information back into any one of the equations before. And it doesn't actually matter. I'm going to use equation 2 because 2 times negative 1 is some easy math that I know we can handle. Okay, so I've replaced the x in equation 2 with a negative 1. And that gives me negative 2 plus 6y equals negative 20. Add 2 to both sides. And divide by 6 to find that y equals negative 3. So we have the answer of negative 1, negative 3. Okay, check out my next video on how to do triples, and then we can get into matrices. But please reach out if you have any questions.